Welcome to chemistry classes. We are in the chapter periodic table. In this session 4. In this session, we will discuss about the classification of elements based on their chemical properties and electronic configuration. Our aim is classification of elements based on their chemical properties and electronic configuration. Now, before going to, we need to discuss about the chemical properties based on their electronic configuration also, because the most of the compounds in chemistry participated by giving the electrons or by taking the electrons or by sharing the electrons, they are participating in the chemical reaction. So the chemical properties of elements is purely based on the electronic configuration. That means chemical properties of elements purely based on electronic configuration of elements. Here take a simple example, second period elements, which are starts from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. When you consider the electronic configuration of these elements, for lithium it is 1s2, 2s1, for beryllium it is 1s2, 2s2, and for boron it is 2s2, 2p1, and carbon 2p2, nitrogen 2p3, oxygen 2p4, fluorine 2p5, and neon will get 2p6 configuration their valency shell. So how many electrons are present in the valency shell is based on the chemical property of the element. Now this lithium, by losing the one electron, that is from the 2s1, it gets the 1s2 configuration, that is equal to helium, inert gas configuration. That's why this lithium always wants to lose the electron in order to form the lithium plus ions. Not only this lithium, the group 1 elements or alkali metals always wants to lose the electron in order to get the previous inert gas element configuration. Lithium will get helium, sodium, by losing one electron it will get neon configuration. Take a simple example here, sodium. Sodium has a inert gas configuration by losing one electron, that is 1s2, 2s2, 2p6, 3s1. By losing the one electron from its valency, that is 3s1, it gets the inert gas configuration, that is 1s2, 2s2, 2p6, which is equal to neon configuration. So sodium can form sodium plus ion to get the inert gas configuration to get the stability. In the same way, if you consider the elements like fluorine and oxygen, all these things, to consider the electronic configuration of fluorine, it is 1s2, 2s2, 2p5. That means what? If it will take one another electron, it gets the configuration like 1s2, 2s2 and 2p6, which is again equal to nearer inert configuration, that is neon. So fluorine group elements, which are called as halogens, are usually take up the electrons from another element to get the inert gas configuration. So it is always wants to form the anions, that is fluoride ion, bromide ion. That means halogens wants to take the one electron in order to get the next element inert gas configuration. The same way oxygen also. Oxygen has configuration like 1s2, 2s2 and 2p4. So if you give the two extra electrons to the oxygen, it can get the 1s2, 2s2, 2p6 inert gas configuration, which is equal to neon. So oxygen always wants to form the bi-negative ion, that is O minus 2. That's why it forms the stable compounds like water and SO2, SO3. In all these compounds, oxygen have bi-negative charge. So this chemical properties of the all elements is purely based on their electronic configuration and the stability of the compounds.